So, finishing the chapter today, this is 5.7. It's all about reflections and symmetry. So, definitions first. A reflection is a transformation that creates a mirror image. So, do you remember when we learned translation? It was just an image, like you'd take the figure and you'd slide it over to make the image. Yeah. Now it's a flipped, okay? So they're related, they're both transformations, but this one is a mirror image, so everything is flipped. The line of reflection is the line that the original image is reflected over. So have you ever, when you were little, like, had a paper plate with, like, some ketchup on it? No. And you, like, fold it, and then you open it up, and now there's ketchup on both sides? Yeah, the crease would be the line of reflection, and the ketchup gets reflected to the other side, okay? I feel like it's like a kindergarten art project, too. You put like half a butterfly on a piece of paper with wet paint, and then you fold it and you open it, and that's pretty much what we're talking about today. A little more sophisticated. Oop, hold on. All right, so right here, the two triangles, they're a reflection, and then the line, this is the line of reflection. So you take a figure, you basically flip it over a line. Everything is backwards. The line is called the line of reflection. All right, here is number 5. So number 5 says, draw the image after the given reflection across the x-axis. Okay, so I always do this one point at a time. Okay? So, which one's the x?
The line going across.
Yeah, the side-to-side axis, right? This guy.
Yep.
So what I do is I go just step by step. I see how far away each point is. Okay? So this guy is 1, 2, 3, 4 away. So you got to go 4 the other direction. 1, 2, 3, 4. I'm going to put a dot. Just stay on that same line the whole time. Don't go left or right at all. Now I'm going to do the same thing right here. So 1, 2, 3, 4. 4 again. 1, 2, 3, 4. All right, so that's like that base of that triangle. Everybody with me?
Yes, ma'am.
Okay. Now, you can either count how far this vertex is from the base or how far it is from the x-axis. I usually go all the way back to the x just to make sure I'm doing it right. So 1, 2, 3, 4, 5, 6, 7, 8 away from the x. I'm going to go 8 in the other direction away from the x. 1, 2, 3, 4, 5, 6, 7, 8. All right. Now use something nice and straight and connect those. And if you counted each point correctly, you should end up with a figure that is congruent and a mirror image. It's just flipped over the line. Again, think of the wet paint. If you had some wet paint and you had a graph with a triangle on it and you squished it, x-axis is your fold, you open it back up, you should have 2 triangles. What are your questions? All right, number 6. Did you guys need me to go back?
No.
Hold on, wait.
All right, now we are reflecting across what? The Y. So now it's this guy. Okay, so make sure you're always going in the right direction. So now I want to see how far away it is from the Y, and then keep going that far to the right of the Y. All right, so I'm going to start at this bottom point. It is 1 away. I'm going to go 1 away.
1 away.
Boom. All right, now I'm going to go here. This is 1, 2, 3, 4, 5, 6. So I'm going to go 1, 2, 3, 4, 5, 6. Now, if you want to connect those now, you can, or if you want to wait till the end, you can. Doesn't really matter. All right, I'll just keep going around the figure. So now I'm up here. This is 1, 2, 3, 4 away. So I'm going to go 1, 2, 3, 4 away. One, 2, 3. 1, 2, 3. All right. Connect, connect, connect. Thank you for the enthusiasm. All right, symmetry is when one shape becomes exactly like another if you flip it, slide it, or turn it. All right, and then a line of symmetry is a line that divides a figure into two congruent parts, each of which is a mirror image of the other. So this is, again, that like butterfly art project I talked about, right?
Yes,
You
ma'am.
take it, you smush it, you open it, you got the same thing on both sides. That's the line of symmetry. So very similar. Lines of symmetry cut one figure, where the line of reflection you'd usually have two figures. But similar idea. Similar, huh? Sorry, I was just making sure there wasn't another one at the bottom. All right, any questions? Here we go. Determine the number of lines of symmetry in the figure.
1.
1.
All right, so you could take the figure. Again, think of the fold. If you folded it, would it line up? It would that way. Now, some of you are saying there's another one or a few more.
Yeah.
There's definitely one. Which way do
Up
you?
and down.
Let's see what we can come up with. So that I think
Diagonal, vertical, horizontal.
I don't think so. Okay, I see what you're saying. But if we go this way, let me try it again. Hold on. If we go like this and we fold it,
It wouldn't look right.
right, like this guy is shorter.
Yeah.
You see how there's like one here
Yeah.
and it's longer, and then you know what I'm saying? It just doesn't quite line up.
No, I don't.
So I see what you're saying, but if we folded it, it'd have like, it'd be like that and then like that. You know what I mean? It wouldn't lie perfectly upon itself. So there's only two here. Any questions? All right, let's try another one.
Watch Lion King.
4.
Why the zebras running through the
So there's definitely 1, 2, right? Those are pretty easy.
Yep.
Do we think there's more?
Yeah, it's 1 o'clock.
Yeah, this one the diagonals will work
Yeah,
because it has the same thing on both sides,
Yeah.
going both diagonal directions. So this actually has 1, 2, 3, 4 axes. of symmetry.
5.
Where would the fifth one be?
Yeah, 4 axes.
So you might have to like mark them as you go, like
Oh yeah, you're right.
1, 2, 3, 4, and then this one is already that one. You know what I mean?
Yeah.
All right, are we good?
Yeah.
Next, determine the number of lines of symmetry in the figure. So let's start drawing them. We got the obvious ones, right? Left
Yeah.
and right.
Simba.
What do you think of the other directions?
Horizontal.
We already did horizontal and vertical. I think the diagonals would work here.
Yeah. Diagonal.
And then the other diagonal.
Yeah, I think we actually, see how,
By B.
so if you slice it through the center of the side, do you see that? The center of the side, that works, or if you go through the vertex, that works too. So there's actually a lot of options on this one.
Yeah, I got some major.
Yeah, this one kind of play eye tricks on you. Any questions though?
No.
All right, go to the arrow one.
It's 2.
So I think this one's only going to be 2. We have the 2 obvious ones, and then the diagonals kind of like that, like elongated one we looked at earlier. They don't quite line up if you go diagonal. So just 2.
The next one 0.
Make sure you're writing the numbers, not just the lines of symmetry. Actually, the number of lines is the answer.
And what was number 8?
Number 8. Can anyone help him out with 8?
4. It was 4.
4.
It was 4.
All right.
0.
Yeah, I originally wanted to put one right here, right?
No.
But this is a little shorter than this.
Yeah.
So this one's not going to have any lines of symmetry.
Oh no, door.
So none is an option as well.
Triangle.
All right, and last question.
1.
Is that the one you were thinking of?
Yes, ma'am.
Yeah, if it's an isosceles triangle, 1 is usually your go-to. All right, that means that bell meant we have half the class left for homework. So you shouldn't have homework over the weekend. You should just do it.